Have you ever stared at a line of code for hours, trying to find that one tiny mistake that is breaking everything? It is a common frustration for every coder. Imagine having a super smart assistant that could instantly pinpoint where things went wrong and even suggest how to fix them. AI tools find errors in code primarily by acting like highly advanced pattern recognizers and static analyzers. They sift through your code, comparing it against vast datasets of correct code, common errors, and best practices to highlight potential issues before your program even runs. The magic behind this involves several sophisticated techniques. First, many AI tools leverage large language models, or LLMs, which are trained on massive amounts of code from public repositories. This training allows them to understand the structure, syntax, and even the likely intent of your code. When they encounter something unusual or a deviation from common patterns, they flag it as a potential error. Think of it like an experienced mentor who has seen millions of lines of code and immediately spots a rookie mistake. They also perform static analysis, which means examining your code without executing it. This can identify obvious issues like syntax errors, incorrect variable usage, or type mismatches. More advanced AI tools delve into semantic analysis. This goes beyond just syntax to understand the meaning and logic of your code, helping to uncover subtle bugs that might lead to unexpected behavior during runtime, such as an infinite loop or a resource leak. Some tools even build an internal representation of your code, like an abstract syntax tree or a ST, to analyze its structure and relationships in a deeper way. So, how do you put these smart assistants to work? Many AI tools integrate directly into your integrated development environment, or IDE, like Visual Studio Code, or they exist as plugins for your code editor. As you type, they provide real-time feedback, highlighting errors with squiggly lines or suggesting auto-completions. When you save your file or run a linter, they can generate comprehensive reports listing detected problems, often with severity levels and suggested fixes. For example, a tool might tell you that a variable is defined but never used, or that a function expects a string but you are passing an integer. They can even offer refactoring suggestions to improve code readability and maintainability, preventing future errors. These tools are constantly learning and improving. Every time they analyze code and receive feedback on their suggestions, their underlying models become more refined. This continuous learning process means they get better at understanding new coding paradigms, different programming languages, and even your personal coding style. They act as a sophisticated safety net, catching common pitfalls and even some obscure issues that might slip past a human reviewer. Some tools can also identify security vulnerabilities, like potential injection flaws, by recognizing dangerous coding patterns that could be exploited. By understanding how AI tools detect errors, you can transform your coding process. They provide a powerful layer of automated review and assistance, freeing you up to focus on the creative problem-solving aspects of programming. This ultimately leads to cleaner, more reliable code and a much more efficient development workflow, boosting your confidence and helping you write better programs faster.
If this helps you code smarter, like, subscribe, and build with us.